So it appears more and more that Tesla will really build a Gigafactory in India. But when can we expect Giga India to start construction? And when will it go online? Then finally, we also have some excellent news from the Hyperloop front.
Meanwhile, Amazon is showing us a first prototype of the Rivian-built delivery van, then a first electric bus running on solid-state batteries, and Boom Supersonic has just unveiled the prototype of their first supersonic aircraft, the XB-1 or Baby Boom. And let's also talk about the Nobel Prize for CRISPR gene editing. A lot of disruption news this week, so stay tuned.
We know that Tesla is currently building 3 gigantic gigafactories on 3 different continents. We have Giga Berlin, which is slated to go online in summer 2021, designed to pump out 2 million cars annually when completely finished. Then we have Giga Texas, which will also go online in summer 2021, targeted to pump out at least 2 million cars per year, possibly even more. Then we have Giga Shanghai, which will pump out 1 million cars per year by 2022. But of course, Tesla isn't satisfied yet with that, because Tesla is an exponentially growing company, and it wants to pump out as many as 20 million cars annually by around 2030, which is, by the way, totally doable already by 2029. If Tesla just continues with the growth rate it had until now, so around 50% of growth per year. So now we have a few more details on Tesla's plans for Giga India. Apparently, Tesla is in talks with the government of Karnataka, which is a region in southwestern India. The city of Bengaluru, formerly known as Bangalore, has been proposed as the location for India's Gigafactory. Gaurav Gupta, Principal Secretary of Karnataka's Commerce and Industries Department, said, quote, "We have offered Tesla all support to set up a research and development center and the manufacturing unit. Bengaluru has a favorable ecosystem for electric vehicles, and Tesla can leverage on that."
Bengaluru is an incredibly fast-growing city with 11.4 million inhabitants, and as you can imagine, air pollution is a real problem there. So having more electric cars and less stinkers on the road in India would certainly make a lot of sense. Just 2 weeks ago, Elon had tweeted that Tesla would enter the Indian market in 2021. We think that realistically, until the deal with the Karnataka government is closed, 2 years might pass, so that we probably will see construction start of Giga India or Giga Bengaluru, should that location be chosen, around late 2022 or early 2023. So a finished Gigafactory in India by end of 2023 is certainly realistic. This is really excellent news because India's GDP is growing rapidly and there is really a strong need for electric cars there. In other news, Amazon has now shown a working prototype of their electric delivery van, which is being built by Rivian. We remember that in late 2019, Amazon placed an order for 100,000 electric delivery vans to be built by Rivian. Yes, the same Rivian that plans to build the electric pickup truck R1T and the electric SUV R1S. We don't have many stats yet for the electric delivery van, but Rivian says that the range will be around 150 miles, which is really good for such a vehicle. The first trucks should arrive at some point in 2021, but of course, Rivian will need quite some time to build 100,000 of these vans.
And please consider subscribing to our channel, because we are the only space channel that not only does space news, but also gives updates on other disruptive technologies out of pure interest. However, this is quite detrimental to the growth of our channel, so we really need your support. Thanks a lot. Another good development is Mercedes-Benz finally realizing that electrification is really happening, and that if they want to survive, they must switch to electric ASAP. They are doing so by switching more and more of their cars to electric. But now they also unveiled an electric bus, which will use solid-state batteries. These batteries will offer a 25% higher energy density than lithium-ion and allow with their 441 kWh battery pack a range of 137 miles or 220 kilometers in summer and 105 miles or 170 kilometers in winter. But since the solid-state battery tech is not so well developed yet, not yet allowing for fast charging, Mercedes will also offer the bus with lithium-ion batteries. But before you get too excited, let's first see when they will manage to put the bus into production and how many they will produce. And now finally, after a longer time, we have some exciting news regarding Hyperloop. Who would have thought that West Virginia will be leading the Hyperloop development charge with a Hyperloop technology demonstration center and a 6-mile test track?
Hyperloop, take me home to the place I belong. West Virginia, Mountain Mama, take me home. Hyperloop.
Anyways, the company behind this project is Richard Branson's Virgin Hyperloop. Last week on October 8th, Richard Branson said in a press conference joined by high-profile West Virginia politicians, quote, "Today we lay the foundations for commercial deployment and operations across the United States of America and beyond. The goal of this $500 million project is not only to validate the technology itself by demonstrating that it works, but also to work together with the government to establish a regulatory framework for Hyperloop and of course also to kindle public interest for that amazing mode of transportation. Because many are still very skeptical about Hyperloop. We certainly experience it every time in the comment section when we mention Hyperloop. It won't work because maintaining the vacuum is far too much effort. It won't work because I saw a video from Thunderfoot, he said it doesn't work, therefore it doesn't work. It won't work because of thermal expansion, you know. Okay, then why do pipelines work? You know, typical naysayer stuff. So construction will start in 2022 and the 6-mile or 10-kilometer long test track should be adequate in order to demonstrate the feasibility of Hyperloop and then to later expand the tube network step by step to build tracks hundreds of kilometers long. We are really looking forward to this, not only to see the stupid faces of the naysayers, but also because this new mode of transport would really totally change the way we travel distances in the range of hundreds to 1,000 kilometers. Another cool mode of transportation many of us already experience is flying in an airplane. While Hyperloop reaches speeds of 600 mph or 966 kph, so around the same speed as current airplanes, we also know that there was a time when we traveled faster than that. Namely, in the time of Concorde, passengers traveled at speeds of Mach 2.04, which corresponds to 1354 mph or 2180 kph. Many companies are working really hard to bring back supersonic passenger flight, such as Ariane with the AS2 Mach 1.6 jet or Boom Supersonic with their planned 75 passenger Mach 2.2 Overture jet.
Now Boom, which is based in Denver, Colorado, has just unveiled the prototype of the Overture, a smaller version of the Overture basically, which they call the XB1 or Baby Boom. The XB1 is 21 meters long and is aimed to test the supersonic flight capabilities in order to enable building the larger Overture. The XB1 will also reach Mach 2.2 or 2700 kph. At these speeds, a flight from, for example, Sydney to Los Angeles would take only 4.5 hours instead of 15 hours. How cool is that? It's really about time that supersonic passenger flight made a comeback, because we still find it quite embarrassing that decades after retirement of the Concorde, we don't have any alternatives. Boom is working really hard to usher in a new era of supersonic passenger flight. And the XB1 is the first important step towards that.
So finally, the time has come to talk a bit more in depth about another big area of disruption, namely biotechnology. Because last week on Wednesday, the Nobel Prize Committee awarded the Chemistry Nobel Prize to Emmanuel Charpentier and Jennifer Doudna, who made key contributions to the development of the CRISPR gene editing system. CRISPR stands for Clustered Regularly Interspaced Short Palindromic Repeats. You know, that old stuff. CRISPR is a family of DNA sequences found in the genomes of some bacteria. They play a key role in the antiviral defense system of bacteria. Charpentier and Doudna discovered in 2010 that one of the CRISPR-associated genes, with the equally cool name CAS9, could be reprogrammed as to cut any DNA sequence and thus enable gene editing. And this of course now opens up a lot of possibilities for bioengineering. An application we can already see today is, for example, CRISPR-based tests for detecting SARS-CoV-2 that work rapidly and at room temperature. But of course the implications go much further than that. CRISPR-Cas9 gene editing will enable to more effectively fight cancer. The first such trial started in the US at the University of Pennsylvania in 2019. This study, which is funded in part by the National Cancer Institute, is testing CRISPR-Cas9 gene editing, where patients' own immune cells are genetically modified to better see and thus kill cancer cells. First results of this study from earlier this year show that these gene-edited immune cells are safe.
Many more diseases will be cured with gene editing. But of course, this form of gene editing could also be used to make us more resilient to space environments, something we often mentioned in our space videos. For example, to make astronauts more radiation resistant, or to increase muscle and bone mass in order to better cope with low gravity environments. And of course, it would also be possible to increase our mental abilities. Imagine this in combination with Neuralink. Insane intelligence could be unlocked this way. But more, CRISPR-Cas9 gene editing can also be used to modify genes which are responsible for our limited lifespans. Thus, we could identify key genes which control the cell divisions in our bodies and the shortening of telomeres. Telomeres are molecule sequences at each end of a chromosome. Chromosomes being those X and Y thingies that carry the human DNA. They get shorter until when they are gone, the cell then dies. Now, gene editing could greatly slow down the shortening of telomeres and also allow us to develop methods to combat the other contributing factors of aging. CRISPR gene editing is already now starting to become a mainstream biotechnology tool. And we believe that in the next 10 to 20 years, many amazing new applications will be enabled by this technology and allow us to live longer and healthier lives.
And in case you missed our video where we explain why we believe that Tesla will be the first $10 trillion market cap company, you can watch this video here.
So thanks for watching the JS Disruption Report, and I would say, on to the future. Really?
Yes.
But I do sound so sad. Do you still eat today again or not anymore?